Let's talk about no display maintenance. First of all, what is no display? To describe this thought clearly is our real main thing. Just press the switch to hear the system bell, but there is no picture. After pressing the switch, the fan also rotates and the inductor light is also on. But you can also hear the sound of the system. We call this kind of failure non-display. The display is divided into two parts, to be clear. Whether the Mac or Windows. The display is divided into two parts, backlight and image processing. In other words, when it is no display, first look at the backlight. Let's use a flashlight to illuminate whether there is an image. If the flashlight shows an image, it means that there is a problem with the backlight. The English name of the backlight is called BL on the circuit, the abbreviation of the backlight. The image is represented by the LCD, LCM display. Whether it's a problem with the backlight or the image, we all have to change the screen to try it. If it still fails after replacing screen, check the screen line interface on the motherboard. How to check the screen line interface? If it's a backlight problem, measure the resistance first. Whether it is a backlight problem or a display problem, we should measure the resistance first. See if there is an open circuit or a short circuit. For the short circuit problem, we basically remove the capacitor. See this test point and open the point map. In the basic class, we had told you how to measure the resistance. Everyone recall the content of the basic course. We simply open the point map, then measure the diode value of the interface to judge whether it is an open circuit or a short circuit. If the resistance is normal, then check the Backlight IC. We all have a Backlight IC on the motherboard, then there is a problem with the Backlight IC. Some models of the Backlight IC are built on the screen, and some are built on the motherboard. If it is on the motherboard, you find the Backlight IC. If it had the two letters of the boost inductor or diode. When the diode value is normal, most of them are caused by the Backlight IC. If it is an image problem, there is no image. It's the same principle. To judge if the problem caused by the image, we should measure the diode value first. If the resistance is normal. If this resistor is not powered, check its power supply. The resistance value is normal. Generally, the data is connected to the graphics card or CPU. At the time we open point map, let's take a look at the thing connected to each pin and then test. It is 3-volt 3-volt power supply. Our screen power supply and image power supply are both 3-volt 3-volt. From level to level, we'll mark it and on the circuit diagram. Let's look at the fourth step at this time. Measuring power supply, resistance value, and routines are the same. When encountering a fault in the interface, we generally use a method to test. The method is to measure the resistance and voltage. The open circuit is repaired according to the open circuit, something to repair the point, something to make the jumper. Generally, the no display problem is solved by the following step we mentioned. If the backlight is normal, it is widescreen. If the image is normal, we can see the image by using flashlight. That's a problem of the backlight. So during our maintenance, if the failure is no display, the problem is relatively simple. Next, we look at the circuit diagram to find out what this backlight display stands look like. Let's take a look at the flat light interface of this motherboard. Interface number J9000, LCD connector interface. Let's take a look. This interface is divided into two parts. The one with LED is responsible for the backlight portion. It is used to control the brightness of the backlight. What about when our backlight is no bright? We want to check the diode value of this interface, including the third pin and the fourth pin of the power supply. NC is empty. We don't care about it. The fifth pin is NC, like the 6th, 7th, 8th, 9th, 10th, 11th. We need to measure the diode value of these pins. And our third and fourth pins are power supply pins. This pin not only needs to measure the power supply, but also resistance value. First test the resistance value and then measure the power supply. If any component of this pin is broken, it will cause the brightness to be low. We repair the interface circuit. Relatively speaking, it is easier to repair as long as there is a drawing. But the premise that the connector cannot be dirty or deformed. First repair from the outside to the inside, not inside and outside. This too needs to be clear. Before we change the screen, backlight is our backlight. Let's take a look at this part below. DP is responsible for displaying images. It has a set of power supply 3.3 volt on our 80 and 90 pins. Its 3.3 volt is our set of level-to-level power supply. From this regulator, let's take a look. The U9000 voltage regulator comes in at 3.3 volt and goes out at 3.3 volt. If this regulator doesn't work, it's easier to break. When you're repairing the machine, if there is no image on your screen, first check whether the regulator is normal. This voltage stabilizer can be repaired without changing. We can connect it with a wire from the second pin and the fourth pin of the VIN pin. If this regulator is broken, it can be repaired quickly. In addition, let's take a look at the output of this regulator to the inductor L9004. This inductor is relatively easy to break, but it can be short-circuited. It adds an insurance. When we measure the resistance and it shows a short circuit, we can remove the C9015 without installing it back. When you are repairing, the R9060 fused resistor is also more prone to damage. When repairing the machine, I have to check the key points. In other words, when there is no problem with our interface, we need to find all the components connected next to the interface, including the beginning of the C on our data line. These coupling capacitors are absolutely indispensable. These coupling capacitors enhance signal transmission, including these pull-down resistors on the interface. In other words, when there is no image, we check the DP part. It is responsible for the image. The following part is responsible for brightness and backlight. When we turn on, there is no display and no backlight. We need to repair this interface circuit. Important thing to check, including the backlight part. These two parts are called I2C bus, which is used to check the screen information. If these two resistors are damaged, it will cause our screen to display a no backlight. These two can be also short-circuited. Both play an insurance role. So it is relatively simple for us to repair the display circuit. As long as there are diagrams, steps, and plans, the maintenance methods are the same. This is the maintenance that is not shown. Let's take a look. If the backlight is not bright during maintenance, this power supply doesn't exist. So where does the backlight come from? It's here. Let's search for its English. Find it, this is Backlight IC. U9701, this is a Backlight IC. It is a boost IC. It is generally under maintenance and it is relatively easy to break. Let's take a look at the U9701. This boost inductor, it relies on the chip to output a square wave. Control the output of the boost inductor on the boost inductor. Turns into direct current through a rectifier diode. Go out to our backlight display interface. Generally, it is a voltage above 10 volt. It can only work at a voltage above 10 volt. In other words, if the backlight has no brightness. Can see picture with a flashlight. You still can change the screen. There is no problem with the diode value of the connector. At this time, you need to repair the Backlight IC circuit. Most of the time, we first check whether the diode is broken. The method of the diode measurement we have to talk about in the course. If there is no problem with the diode, then look at this inductor. Measure the quality of this boost inductor. If there is no problem with the boost inductor, we directly replace the Backlight IC. This is second step. This is third step. If you change the boost IC, it won't work. Everyone focus on checking this zero-ohm resistor around. The zero-ohm resistor that plays a role of insurance is very easy to break. Remember here. When there is no backlight, the important point is the circuit. Relatively speaking, the probability of being bad is relatively high, including these zero-ohm resistors. Including this resistor, such as R9757 and R9753. You must check and pay attention to them. If it doesn't work after changing the Backlight IC, check the surrounding components. This is how to repair the backlight circuit. See you in the next class.